Good evening. In previous session, we have seen the concept of synchronization, and to implement the synchronization in Python, we are having three methods. One is lock, second one is RLock, and third one is semaphore. So in previous session, we have seen the concept of lock. So before going into RLock, what is the need of going into a new methods? If there is any uh, drawbacks are there in our current method, then we are going for a new methods. Otherwise, if there are any additional features are there in new methods, then we are going for new methods. Otherwise, what happens? We will use the current technologies only. For example, I am using one mobile phone. Let us consider I am using one mobile phone which is having camera 5 megapixel, and it is having mp3 player and everything. It is there in our mobile phone. So now I am using this mobile phone. In future, after 1 year or 6 months, a new phone was released, that is 8 megapixel we are having camera. That means what? Here we are having only 5 megapixel, so the some advanced feature is there, so that I can go into a new phone. I will go to new phone. So this is one thing when we are going for new technologies. Another one is, if there is any drawback, that means some feature is missing in this one, and that feature is available here. For example, here only back camera is there. Okay, there is no front camera. Rear camera is there, there is no front camera. For example, here we are having both front and rear cameras. Both cameras are there. Here, what is the disadvantage? Here we are not having rear camera. This is the, sorry, front camera, not rear camera, front camera. So that here we are having what? Front camera and rear camera, both are there. So that this is the disadvantage here. Okay, for that I am going to new mobile. In the same way, here we are going to other technique, that is called as RLock. So before going to see that RLock, now we are going to see what are the disadvantages of lock concept. Then we can go to RLock. So just I will show you some of the problems that are going to be arised here. First one is, if you are going to write one small example, I will take here. If I am going to consider a small example, just I'm going to write a small example. So generally, from which module you are going to import? From threading module. From threading module, I am going to import all these classes and functions. And next, what I want to do, just I want to create a lock object. For that, just I have to create some reference name equal to lock. Just I want to print what? Just I want to print acquiring a lock. Acquiring. Okay, now I want to apply a acquire. So I am going to acquire the acquire method. I am going to apply here. Now I am going to print in this acquire method. I am going to print releasing. Okay, right. Next, after this I am going to apply release. So here, how many threads are there here? There is only one thread. Which thread is there? Only main thread is there. Here I have not created any thread here. There is only one thread, that is a main thread. Is there any mechanism to know here which thread is going to execute? I cannot understand. By seeing I can understand, but internally I cannot understand which thread is going to acquire the lock or release the lock. Okay, so now here just I will execute this program. As there is only one thread here, there is no problem of synchronization. There is no need of synchronization here. Anyway, I have applied the concept of acquiring and releasing. Now here the problem is, unfortunately, while writing this one, unfortunately I forgot to write this statement here. So what is the concept here? Without acquiring the lock, how can I release the lock? Is it there? So if I am going to acquire the lock, I can release. Without acquiring the lock, how can I release that lock? So that means what? Here we are going to get what? We are going to get an error. That is what? Release unblock, unlock lock. That means what? I am not going to lock anything, but you are trying to open what? Unlocked lock. That means that the lock is not locked. You are trying to release a unlocked lock. Okay, this is the runtime error we are going to get. So let us consider. Here I am going to remove this one, and just I am going to comment this line. Now what happens? I have acquired the lock. I have acquired the lock and I am not releasing the lock. Will there be any problem? We will not get any error. Reason is, If there is any thread is there, any other thread, then it will wait for how much time until the, what we can say, the thread is going to release that lock, other thread is going to wait. But here there is only one thread is there, so there is no problem here. If multiple threads are waiting for a, if multiple threads are waiting for a lock, if one thread is going to acquire the lock and if it is not releasing, then what happens? It leads to a deadlock. What is meant by a deadlock? Just briefly I will explain about a deadlock. Deadlock means it is going to wait for a lock. It is going to wait for a lock until what? Until infinite time. It is called as deadlock. If any thread is going to wait for a lock until infinite time, then that type of situation is called as deadlock. Will that particular thread is going to get any lock? No, it is not going to get. Reason is what? Without releasing the lock, the main thread is going to complete. Then who will release? For example, I am going to lock the room. For example, I am going to lock the room and I went to my home. Who will open that? I am not there. My task is completed in my office, so that I have locked the room and I went off. So what happens? If anybody want to open that one, they have to wait. Let us consider I have resigned that job and I have left that country. I went to other country with that particular lock. I have not released that lock. Then what happens? For example, that if there is a lock only, they can enter into that room. Then what happens? They cannot enter into the room in their lifetime because the lock is not there. Okay, so that here there are some problems. So these are what, if you are not going to release the lock, then there is a chance of getting a deadlock. Then there is a concept of deadlock here. Otherwise, if we without acquiring a lock, if you try to release, what happens here? Then there is a error, runtime error we have seen. Okay, without locking, how can I release? What I have to release? Okay, right. Now one more problem, main important problem I am going to discuss, that is here. For example, here, which thread is going to acquire the lock? Do you know that as I am seeing this lock, I can understand that main thread is going to acquire, but generally I cannot understand which lock is going to acquire here, because is there any mechanism to know which thread is going to execute here? No, I don't have. That means what? Here, who is the owner of this lock here? Who is acquiring lock? Here, main is going to acquire the lock. Okay. Next, can I know it? If it is a large program, is there any mechanism to know which thread is the owner of that particular lock? It is not possible. Okay. Next one. Here in this example, for example, who is the owner of the lock here? Who is acquiring the lock? Main is going to acquire the lock. How many times it can acquire the lock? Only once it can acquire the lock. That means, for example, here I am going to write acquire. I am going to write acquire lock. Okay. After that, I have written some statement, print of releasing 2. For example, releasing 2 I am going to write. Here, what happens here? I have written only one L dot release. Observe carefully here. Acquire lock, acquiring and releasing is printed here. Is there anything? So what happens here? First, what happened? Acquiring is printed, releasing is printed. Next, it has acquired. Observe carefully, it has acquired. Next, before releasing, is it possible to acquire here? No, it is not going to do some. No, it is not going to acquire. Reason is what? Observe carefully here. Here, the main thread has acquired the lock. Main thread has acquired the lock and is executing this statement. Once again, it got L dot acquire. Already it is having, what we can say, lock is there. Again, second time it will not hold. Okay. Okay, that means what? Here in this example, main is the owner of the lock. We know that. But if that main is trying to acquire the lock once again, the program will be what? The program will be stuck here. It will not be executed further. That means what we can say here, this lock concept is going to fail in some cases. When it is going to fail? If the same lock is going to be applied multiple times, okay, then this lock concept is not going to apply. When there is a need of applying multiple times, there is a need of acquiring lock. In recursion concept, we will apply. What is that? In recursion. That means this type of lock is not used for recursion concept. So this is the disadvantage we are going to see in our lock. Once again, I'm going to explain the concept. So observe here L dot acquire. Who is acquiring this lock? Who is executing all these statements? Main is going to execute, so that it has acquired the lock and it is going to releasing. For example, it has printed some statement here, not releasing. It has printed some statement. For example, hi, it is going to print. Okay, it has printed hi. After that, once again, will it acquire the lock? No, it will not acquire the lock. Reason is already it is having the lock. Once again, that means what, multiple times the same lock is not going to be acquired in the concept of lock. The lock object cannot be acquired multiple times by the same thread also. So that here the program is going to be structured up to what it is going to execute. Acquiring will be executed, high will be executed. Next, the program is not going to be executed here. The reason is second time I am trying to acquire the lock. It is not possible by using the concept of lock. So where these type of situations arise? In the concept of recursion. Okay, for example, I will take here. What is meant by recursion? A function calling itself. For example, I'm going to take factorial function. Here once again I'm going to pass what? Fact of n minus 1 I'm going to pass. See here I have applied what? The concept of L dot acquire I have applied. After completing L dot release I'm going to apply. So see here from this statement n into I'm going to write fact of n minus 1. Already once we are coming from this way, I have applied L dot acquire. Once again it is going to call. Same thread is going to call. Observe carefully. Same thread is going to call the function. Once again we got what? L dot acquire. What happens? Will we get the output here? We are not going to get the output here. Because if we are going to use the concept of lock, it can acquire the lock only once. It may be same thread also. Same thread cannot acquire the lock multiple times in the concept of lock object. For that, we are going for the concept of RLock. So just I will show you this disadvantage by writing a small program so that you can understand what is the disadvantage of this lock. So that I am going to show you one more mechanism, that is what? RLock. So now just I will write a program for factorial. Already we know that what is meant by factorial. So that just I will write this recursion concept. I will show you recursion concept by using the program called as factorial. Just what is meant by factorial? 5 into 4 into 3 into 1. That means what? N into n minus 1. After that n into n minus 1 and so on. It has to be continued until we got 1. Okay, right. Just I will not do anything here. I will not implement any lock concept here. Okay, without implementing lock concept, first I will write the concept of factorial. What it is going to receive? Just it is going to receive one number to which we have to perform a factorial. Now if already we know the logic, if n equal to 0, in that case it has to return what? 0 factorial is what? 1. So that I am going to return what? Return result. Or we can write here, we can write a result equal to 1 also, there is no problem. Result equal to 1. Okay, right, completed. If it is not the case, else case, I will go to else case, and here if the n value is 5, what I have to do? 5 into 4. After that 4 into 3, 3 into 2, 2 into 1. It has to be done. So just I am going to write some result res equal to n into n means what? 5. 5 into what I have to done? 4 into 3 into 2 into 1, which is nothing but a 4 factorial. If I consider 4 into what I have to do? 3 factorial. Again 3 into what I have to do? 2 factorial. Just I will demonstrate that one. Here what is the value I am going to take? 5. 5 into what I have to do? 4 factorial. I have to perform 4 factorial. After that 4 into what I have to perform? 3 factorial. Next 5 into 4 into 3 into 2 factorial I have to perform. After that 5 into 4 into 2 into 1 factorial it has to perform. After that 5 into 4 into 3 into 2 into 1 into 0 factorial we have to perform. So as I have written one base condition for this one, 0 factorial is nothing but it is going to return what? 1 only. So there is no problem. Finally we got answer as what? 5 into 4 into 3 into 2 into 1. We got some 120. Okay. right? This is in this way we are going to apply. This is what n value, n into which factorial I have to do, n minus 1 factorial. After that, now n minus 1 is what? N minus 1 is nothing but 4. So for now, the factorial program will be continued for 4. That means what? 4 into n becomes what? 4. 4 into n minus 1 factorial. Now for 3 factorial, the same function is going to be called. Now what happens? N becomes 3. We are going to perform n minus 1 factorial. Again, it is going to call same function. Now what happens? 2 into 1 factorial and so on. If you are going to get the value of n as 0, then it is going to return what? 1. At this position, the program is going to be, the condition is going to be terminated, failed. So that what I have tried here, n into fact of, so I have written what? Factorial. Okay, factorial of n minus 1. This is the logic. So after that, what happens? After performing all these things, just what we have to do? We have to return result. Return result I have to write. Otherwise, here I have written what? RES. Anyway, you can take anything. There is no problem. Just I will written what? Return result. This is the concept. This is the factorial concept. Now, just what I will do? I am going to call factorial program. So just I will call a function called as factorial. Factorial of 5 I want to perform. Anyway, as it is going to return some result, I am going to print this one. Print of, I am going to write factorial of 5. Next, I am going to write print of factorial of 6 I am going to write. Observe here there is no concept of multi-threading. Only one thread will be there. First it is going to perform 5 factorial. After it is going to perform 6 factorial. If there is only one thread. Now I want to use the concept of multi-threading. So if I want to use the concept of multi-threading, I have to create the threads. Okay. So here target should be what? Observe carefully here. If I write target as factorial, observe carefully. If I write target as factorial, something is going to be returned here where I have to store. For that, I am going to take one more function, that is define result function. I am going to take, because just it is going to take the result. That's it. So here I will print, just I am going to print what? Factorial of. So for this result also I'm going to pass some n value. So factorial of n value, just I want to print n. The whatever the value it is going to pass, just I'm going to print that one. Is, where will be the result? So sorry, which function I have to call here? Factorial. From here I'm going to call, so that the result is going to return to here only. Factorial of n I am going to take. Now observe here. So this is not the case now. Now I'm going to create two threads. First thread is what? Sorry, for this target is what? Target equal to this one, or this one, or this one. We are going to call this one only. Okay, because from here I am calling factorial. So result I am going to call, and I want to pass one argument for this one. Okay, that is, first I am going to pass args equal to, first I will pass 5. Observe carefully, 5 I am going to pass. Already we know why we have to pass in this way. Next, thread 2 I am going to take. Same thing I want to create, that is what? For second thread also I want to use same thing, but here I want to use 6. Same way for thread 3 also, I will create 3 or 4 threads. So I am going to write here some 7, for example 7. Okay, right. For thread 4 threads I will create. Okay, here I am going to write some 3, for example. So these are the 4 threads I am going to create, and now I want to start. Just I have to write what? T1 dot start. Next, T2 dot start. So before going to run the code of a thread, we have to apply which method? We have to apply a start method on a thread. Then only it is going to execute our target method or target function. If you are not going to write any target here, compulsory which method will be executed? Run method will be executed. Now observe here, just I have written a code here, that's it. So just I will give you a line spaces here so that you can understand clearly about this program. So what I have created, just I have created one function where I'm going to call factorial. So for that only I'm going to create this one. If I write target equal to factorial, what happens? The result cannot be stored here. Okay, so that I'm going to create define result, and here I'm going to write call the factorial. Now observe carefully here. If I execute this code, what will be happen? Let us see now. So just I will explain in our command prompt, python space test.py. I'm going to write test.py. Is there any concept of synchronization here? That means, is there any lock? Is there any RLock? Is there any semaphore? There is no concept. So just I'm going to apply multi-threading concept. That's it. See what happens. 120, 720, 50, 6. Okay. That means what? T1, T2, T3, T4. I can't expect here, but I 5, 6, 7, 3 as I have passed, it is going to be executed anyway. I will execute multiple times. So let us try here. So no problem, we are going to get same output only, as we are having less number of threads here. If I take more number of threads, let us take T5 also, T5, T6. If I take, what happens? Automatically the order will be changed, as we are having less number of threads here. And also we are going to start what sequentially. If the function is very large, then we can understand. So here already we know that if you are not going to apply the concept of synchronization, all threads will be executed at the same time. So that here target is what? Result. So it's all are going to execute on this result. First, which one I started? T1. So T1 will come first, and so on. We cannot say T1 will execute completely first, because here as the code is very less, we can't what we can say, we can't observe the difference here. But if the code is somewhat large, you can understand clearly. So if execute multiple times, also same code is there, so that it will give you the same answer, as the code is very less anyway. Now our concept is what? I have to apply lock. So for this one, I want to keep the concept of synchronization. For that, I am going to apply the lock. First, I will apply lock concept, not RLock. First, I will apply the concept of lock here. So how many what we can say, how many threads can apply? So how many threads has to execute this factorial at a time? Only one. Now observe here, acquire. I am going to write, and here after completing our process, that is here I will take, where our process is going to come started here and ending after this one. Okay, so L dot release I'm going to apply. Now see what happens. Observe carefully. Here you may not observe the output, just I will take in a command prompt. Now observe carefully what happens. It's gone blinking. It is not giving any output. Reason is what here? Why it is blinking all the time? It is not going to give any result. Reason. So once if I am calling this function, first thread comes here, and here it goes here. First thread went here and it acquired lock. First thread is going to acquired lock. Which type of lock it is? Normal lock. Okay. So is n value is 0, not 0. So it will go else case. Result equal to n value is what? 5. 5 into factorial of 4. Again, before going to release that lock, I am going to acquire the lock once again. Is it possible with the concept of lock? It is not possible. So this is the disadvantage here. In lock, we are having one disadvantage, that is what? We cannot apply same lock multiple times. If the owner also cannot apply multiple times. Okay, that is the disadvantage. For that, we are going for the concept of RLock. So what is the advantage of RLock means? Just I want to tell you one point. So whatever the disadvantage we have seen there, that will become what here? Advantage. Okay, what is that advantage here? That is, to overcome this problem, we have to go to which concept? RLock. Just I will write the name RLock. What is meant by RLock? Re-entrant. Otherwise I can say re-entry. What is meant by re-entry? Once again it can enter, there is no problem. re-entrant lock. There is no problem if you are going to lock once again also. Re-entrant lock. If you are going to apply the lock second time also, there is no problem. Okay. That means what? Re-entrant lock is nothing but what? A thread can acquire same lock. A thread can acquire same lock. Already we have seen the scenario. Same lock again and again. There is no problem. Again and again. Okay. This is the advantage of this RLock. So here, if the lock is held by, for example, if the second scenario, this is if the lock is held by, other threads, if it is not the owner, other threads, then only the thread will be blocked. That thread will be blocked. Okay, very important point. Once again, I'm repeating the concept. So a thread can acquire, by using the concept of RLock, that a thread can acquire same lock multiple times, or again and again. We can say if the lock is held by other threads, then what happens? Automatically the thread is going to be blocked. Okay, so very important point. This is re-entrant, or we can say what, RLock concept is available only for the owner thread. That means, let us consider here some lock is there. Who can lock this one? Only owner of that particular lock. Those who are going to acquire that lock, those only can apply multiple times acquire. Once again, I'm repeating. Let us consider T1 has applied L dot acquire. That means what? T1 is going to have the lock. T1 has acquired the lock. So if it wants to acquire the lock second time also, there is no problem. Third time also, there is no problem. Now, T2 want to apply lock now. Is it possible? Who is having that lock now? T1. How T2 can apply the lock on L? It cannot acquire the lock of L here. Okay, T2 cannot acquire the lock L. Reason is, this facility is available only for the owner thread, but not for other threads. So for these threads, it is not possible. Only this thread, who is the owner of this lock here, T1. So this T1 only can apply multiple locks. There is no problem. No other threads can apply if one lock is if the lock is with other thread. Okay, right. Re-entrant. Remember the name. What is that? Re-entrant. Re-entrant means what? Multiple times it can acquire. So just I will explain here. If I take the concept of just I will change only R here. Just I will place R. Then the entire program will be executed. There is no problem. Observe carefully. So just I am going to do what? Here, see here, the program has not yet stopped here. Just I have to press what? I am pressing Control C. Control Z, it is not working. What we have to press? Control break I have to press. What is that? Control break I have to press to exit from the situation. So now see, once again I'm executing that program. So what happens now? I got the output here. The reason is what? I am going to apply the concept of what? RLock. If you are going to apply lock concept, then what happens? We are not going to get the answer here. So what is meant by RLock? We will see the scenario, but here we can observe what? Multiple times in recursion, the same lock is acquired by the same thread. First, let us consider T1. T1 is calling which method? Okay, result function is going to call. So first T1 and next T1 came here first. So it went to this factorial. At the same time, T2 came here. T2 also coming here. But first T1 came to factorial, so that it is acquiring the lock. Observe carefully. T1 acquires the lock. Then what happens? If now T2 also came here. Now already this lock is acquired by whom? The lock is acquired by T1. Can T2 can enter into this area, this critical section? No, it cannot enter. So what? T1 is executing this code. Now it came here. Observe carefully here. Now what happens? Who is executing this line? T2 is going to T1 is going to execute this line. That means what? It is going to call the same function, recursion. Now what happens? Who came to execute this factorial? Thread 1 only. Again, who is going to acquire the lock? Thread 1 only, because thread 1 is owner of that lock. Already first who acquired that lock? Thread 1. Again, it can acquire or not? Yes, it can acquire if it is a RLock. If it is a normal lock, it cannot acquire multiple times. We cannot acquire if it is a normal lock, but it is a re-entrant lock, so that the lock can be acquired multiple times. So second time lock is acquired, third time, fourth time, and so on. After that, for every acquire, we are going to have what? Release. There is no problem. For every acquire, we are having release. For that, for these situations, for recursion concept, normal lock is not going to be applied, or we cannot use a normal lock. So that we have to apply what? RLock. Okay, right. Now just I will give you a small scenario so that the concept will be very clear to you. Okay, right. Now see, here I am going to create a lock. For example, I am going to create a RLock, and I want to apply acquire. So acquire, and I'm going to write some statements here. L dot acquire I have written. How many times I have applied acquire here? For example, thread 1 came here to execute. T1 is coming to this, and T2 also coming to the same function. For example, first T1 has entered, so T2 has to wait. Now T1 acquired the lock. While it is executing this one, again T1 is applying lock. Again T1 is applying lock. How many locks it is there? It is having 3 locks, or sorry, we should not say 3 locks. 3 holds it is having. There is only 1 lock, but it is holding how many times? 3 times. First time it acquires the lock, 1. Second time it is holding, already it is acquired the lock and it's holding. Second time already lock is there, again second hold. Now third hold. How many holds are there? 3 holds are there here. Now I want to release for everything. So release. How many locks are? How many holds are released? Only 1. So already 3 holds are there. It will by using this release, remaining how many are there? 2 are there. Next I am going to apply L of release once again. Then how many holds will be there? Only 1. Next, if I am going to apply L dot release, how many holds will be there? 0. That means by seeing this scenario, what we have to understand? So the number of acquires and the number of releases should be same. Okay, the number of acquire calls and release calls should be matched. If I'm not going to use this scenario, what happens? Automatically we are going to get an error. Let us take this scenario. I think this is clear for you. Okay, now I want to show you an example of the thing what I have explained now. Just I will remove all these concepts. Okay, completed. Now just I will take a small scenario. That is what? L dot acquire. I'm not going to write anything here. Just I'm going to write what? L dot acquire. And here I am going to write again second time L dot acquire. And third time also I'm going to take L dot acquire. After this, how many acquires are there? 3 are there. Just I will release only 2 times, for example. So here L dot release. And again I'm applying what? L dot release. Now I'll save this program and I will execute. Let us see what happens here. So see here, it is not going to do anything. Okay, 1 minute. Let us save this one once. Is not going to tell anything. The number of acquire calls and release calls should be matched. But here what happens here? It is not going to be matched. So here what happens means this RLock is going to track the recursion level, and hence for every acquire call compulsory what should be there? Recursive, what I can say, release should be there. Release should be there. That means number of acquire calls and release calls should be matched. Then only lock will be released. Otherwise lock is not going to be released. That's it. If when what we can say, if the lock want to be acquired by another thread, compulsory lock has to be done what? It has to be released. Otherwise we will not get any error. There is no problem. But if any thread is waiting for this lock, then automatically that thread will enter into deadlock. Very important concept. Here we will not get any error. How many acquires? First acquire, second acquire, third acquire. So first release, second release. Whatever third release, I'm not releasing. If you are going to acquire the lock and if you are not releasing it, what happens? Automatically, if any thread is waiting for that particular lock, automatically that thread will enter into deadlock state. What is meant by deadlock state? That thread will wait for that lock until it's infinite time. It will not get any way. It's on waiting for that particular lock. Here it is not there. Only one thread I have taken, so that there is no problem here. If you take multiple threads, the lock will not be released in this situation. We are not going to get any error. There is no problem. Let us take one more scenario here. Here I am going to write L dot release, and I will remove one. Observe guys, I am going to remove one release here. Now what happens? Automatically we are going to get what? Cannot release unacquired lock. That means that I have not acquired the lock. How you are saying to release? So for this acquire, this release, for example, that I am matching. That's it. Two acquires are there. Two releases are there. So what about this release? For what you are going to release? I am not having any lock. Then what you are releasing? It is not possible. So if you are acquiring, if you are not writing release, we will not get any error. But lock is not going to be released. Next, without writing acquire, if you are writing release, we are going to get an error, because without acquiring a lock, how can you say to release? I don't know what is that lock. Just I'm going to tell you what? An error. Okay. So this is the concept. Here mainly we have to understand 2 points. What are those 2 points? Let us discuss now. That is very important point. First one is, who can acquire the lock multiple times? Only owner of that thread. Owner of thread means already you know. Already owner of that thread. Owner of thread can acquire lock multiple times. Multiple times. For example, I am having a lock. I am having a lock. So this is a lock, for example. So what I am going to do, I am the owner. First I came to this lock, so that I have hold this one. So I am the owner of this lock. I have acquired the lock. So again, if I want to apply second time, no problem. Third time, no problem. Fourth time, no problem. Can T2 can apply or acquire this lock now when T1 is holding this one? No, it is not possible. So that only the owner of that thread, who is the owner of the thread now? T1, can acquire a lock multiple times. For example, it has holds 4 times, for example. So it is applying release, 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 release 4 times. Now T1 is not owner of that particular lock, because it has released that lock. Now for example, T1 is acquiring the lock. Now who is the owner of this lock? T2. Now T2 can apply any number of acquires. So 1, 2, 3. It is also applying what? 4 locks. Or it is acquiring 4 holds of a lock. Then if T1 is trying to acquire the lock, is it possible? It is not possible. Okay, that is the meaning of this statement. Only owner of the thread or owner of a thread can acquire the lock multiple times. No other one can acquire the lock. Now next statement is, number of acquires should be equal to number of releases. Okay, number of release methods. Reason is what? If it is not going to be matched, will there be any error? In one case there will be error, in one case there will not be error. In which case we are going to have the error? If, just I am going to give this scenario once again here. If we are going to write acquire, 3 times, in the last example I have shown you, I have taken how many times? 3 times here. And I am going to write what? And I am going to write release only 2 times. Then what happens? Will there be any error? Here we are not getting any error. But what happens here? If any thread is waiting for this lock, then what happens? That the lock is not released by this thread. Let us consider T1 is holding this lock now. So if T1 is not releasing third hold, then what happens? This T1 is the owner of that particular L. It is not leaving it. T2 is waiting for that lock. T2 is waiting, but it is not released it, and it went off. That means what? The task of the T1 is completed, and it has not released this lock third hold. It is not releasing. So who is the owner of now? Who is the owner of that particular lock? T1 only. But T2 is waiting. So if they release, I will take. T2 is waiting. So on, it is waiting. But already what happens? T1 is completed its task and it left the process. It's going to leave that particular concept of execution. Then T2 will wait until what time? Until infinite time. Because if there is T1, it may release, but T1 completes its task. So it's not possible to release. So T2 will wait for what? Infinite time. So what happens? If it waits for infinite time, it will enter into deadlock. But there is no error here. Next scenario. Let us take here L dot release and L dot release. Now how many acquires are there? 3 acquires are there. 3 acquires are there, 4 releases are there. Without acquiring a lock, can I release a lock? Without acquiring, how can I release a lock? Without locking a room, how can I open it? You are telling that open the door, open the door. Already lock is, if there is a lock, I will open. If there is no lock, how can I open? Already it is opened. So that what happens here? Without acquiring a lock, I can't release. That means what here we are going to get the error. So these are the cases you have to understand about the concept of lock. Okay. Now we have completed 2 scenarios. First one is what? Lock concept, and second mechanism is RLock. RLock is nothing but what? Re-entrant lock. So here just I will give you 1 or 2 points or 2 differences about this lock and RLock. So how many times a lock can be acquired? Only one time. Only one time, or 1 minute. Only one time by a owner. Okay, by the owner. Right. Next, how many holes can be there? It any number of holes. Any number of holes, or we can say multiple holes by the owner. By the owner of that particular thread. Okay. Right. Next, second scenario. Is it suitable for recurrence functions? It is not suitable. So it is not suitable for recursion concept, for recursion. So is RLock is suitable? Yes, RLock is suitable. Is suitable. Okay, for what? For recursive functions or for recursion concept. Okay, right. Next, one more difference I will tell you, that is here it will not track. It will not track the owner. Here I should not say the owner. Only one time by the thread, because here we cannot track. We cannot track the owner. We cannot track the owner, so that it cannot acquire second time. We cannot track the owner. Next, what about this one? It can track the owner, so that it can apply second time also. Okay. So what it can do? It can track the owner. It can track the owner thread, or we can say owner, and also it can identify. It can identify number of holes. Identify what? Number of holes. So these are the differences between lock and RLock. Now I think it was clear about this lock and RLock. Now very important concept we are going to discuss. That mechanism is called as semaphore. Semaphore is very important concept. So here what is the thing we have to observe here? Lock is only we can only acquire lock once by using the concept of lock mechanism. I cannot acquire the same lock multiple holes. I cannot hold the same lock multiple times. When there is a need of holding the same lock multiple times, when we are using the concept of recursive functions, there is a need of holding the same lock multiple times is required. So that is not possible by using lock. So that I am coming for what? I am using the concept of re-entrant lock, which is nothing but a RLock. Okay. So already I have differentiate between that lock and RLock also. Now third mechanism, which is very powerful mechanism. Right. Now observe very careful. Why I am going to semaphore, I will explain now. So till now lock is there, RLock is there. How many threads at a time can hold the lock here? Only one. But multiple holes can be there. There is no problem. Multiple holes can be there. There is no problem. But now the scenario is, for example, here this can be used for the concept of this is recursion. I can use this is what just for a basic fundamental lock it is. I can take example as trial room here for these two. At a time only one thread can enter. One person can enter into a trial room. Now the scenario is I am going for internet center. Internet center I am going. So that today 10th class results. For example, it is a olden days. It is 2004 I will take. Okay, 2004 I will take. So to get the result before 2004, it is 2001, 2002. What happens is they will publish the results in a paper, evening paper they will publish, so that we have to buy that paper. But from 2003, 2004 onwards, what happens, we are internet is very, it is very popular, so that internet was spread among the population. So that, let us consider, I want to enter into a internet center, but here it is a result day, so that many people are waiting to enter into this. There are many people to enter into this internet center, but how many systems are there internet center? There are 4 systems, but how many threads are, how many people are waiting to enter into that internet center? This is the internet center. Okay, how many are there? 1 2 3 4 5 6 7 8 9 10 11 12 students are waiting to enter into the this internet room. Here, if I use the concept of lock or RLock, for example, to get a result of one student, it takes 2 minutes. 2 minutes, for example. How much time it will take for 12 students? 24 minutes it will take, if we apply the concept of lock or RLock. Next, so here 4 systems are there, so I can allow at the same time how many? First student, second student, third student, and fourth student. That means simultaneously how many threads are going to be executed? 4 threads. Why it is only 4 threads? Because there are 4 systems. I am going to allow four people at the same time, because there are 4 systems. I'm not allowing more than that. Okay, so now what will be the time? So 4 into sorry, how many times? First 4 students, 2 minutes. Second 4 students, 2 minutes. Third 4 students, 2 minutes. How much time it has taken? Only 6 minutes. So that here the number of threads that are going to execute the synchronized method or synchronized code, we can allow more than one. There is a chance of having what? We can allow more than one. So this is the main advantage of our semaphore. What is the disadvantage of your lock and RLock? So the main disadvantage of lock and RLock is only one thread is allowed to access at any particular time. Their multiple threads cannot be accessed simultaneously. This is the main disadvantage of lock and RLock. Okay, so in this scenario, what happens if I do with a only one thread at a time? The time will be very huge. But so that here I can allow 4 threads or 4 students at the same time. So in this type of scenarios, we have to go for the concept of semaphores. So this is the advanced mechanism in the synchronization. Okay, if you want to limit to 1, we can limit, but if you want to limit to more than 1 also, we can limit. But in the concept of lock and RLock, compulsory how many threads has to execute? Only 1. Can I make it to 2? It is not possible. Can I make it to 3? It is not possible in lock and RLock. That concept will be, lock concept will be applied by only for 1 thread at a time. Only 1 thread can acquire lock. Okay, it may be number of folds, there is no problem, but only 1 thread. But in the concept of semaphore, I can go for multiple threads can access the shared resources. Okay, right. The concept is what? Semaphore can be used to limit the access to the shared resources with limited capacity. That is nothing but what? Here, how many people, how many students can I send to an internet center at the same time? That is what? 4 students. It is limited. Okay, I can limit that. Right. Now just I will take the syntax of the particular semaphore. How to create a semaphore, I'm going to show you. The class name we are going to use here is nothing but semaphore class. Okay, what is the name of the class? Semaphore. So in the same way, however we have created the concept of lock and RLock, in the same way we are going to create the semaphore here. But here in bracket, what can I pass? I can pass number of threads that can be accessed. Count I have to pass. What I have to pass? I have to pass the count. So here this count is going to represent what? This count is going to represent maximum number of threads. Maximum number of threads allowed. Maximum number of threads allowed to access what? To access simultaneously. That means how many threads has to execute simultaneously? That number has to be given here. Sir, I don't want to give any number. If you are not going to give any number, by default, it will be 1. It will be 1. That means what? If you are not going to give any number, at a time, how many threads can be executed? Only one thread can execute. Okay, right. Next, very important, I'm going to explain now. Listen now. So how it is going at a time? For example, I am going to take one scenario here. S equal to semaphore of 3 I am going to take. Observe carefully here. I am going to take what? Semaphore of 3. So how many are allowed to acquire the lock at the same time? 3 can acquire the lock. How many? 3 can acquire the lock here. There is no problem. Now observe. First one is going to acquire. S dot acquire. So how many more can acquire the lock? 2 more. So that here count value is going to be decreased. Count is going to be decreased to count minus 1. That is nothing but 2. How many more can execute? 2. So now once again one more thread is going to acquire the lock. Now what happens once again? Now count is already 2. Now it becomes what? 1. How many can acquire now? 1. One more. So here it has one more thread has acquired the lock. So 1 minus 1 is what? 0. So now if I try to acquire the lock, s dot acquire, can I acquire the lock here? No, because 3 different threads has acquired the lock. Because now count becomes what? 0. If count becomes the 0, the lock cannot be acquired by one more thread. We cannot acquire. Then no threads can acquire the lock if the count becomes 0. Now when other thread can acquire once again, that means see this one. Now let us consider s dot release. Whenever I am going to apply the concept of acquire, then we are going to decrement. Now if I'm going to apply the lock or the release, that means what? Lock is going to be released. Lock is going to be released. That means what? 0 plus 1. Now one lock is available. Now once again s dot release. Second thread is also releasing the lock, so that 1 plus 1, 2 is there. Now if once again if I want to acquire the lock, is lock is available? Yes. 2 more threads can enter in acquire the lock. So now what happens here? 2 minus 1, 1. Next, can I acquire one more lock here? Yes, I can acquire because the value is 1 is there. Now 1 minus 1, 0. If I try to acquire the lock, is it possible? No. Reason is here already the value of the count is what? 0. So that I cannot acquire. Whenever the threads are going to be released, at that time I can acquire. There is no problem. Okay, right. Now let us see the same program. One small example I'm going to consider here so that you will get a clarity on this concept. So just I will take a small example here. Okay, in the place of this RLock, I'm going to take what? Semaphore. So as I'm using starting letter, just I will write S here. Generally, what are the names that I have to write here as a object names or references? Just we have to use the small letter of the class, starting letter of the class name. So here capital S is there. I'm going to use what? I'm going to use the concept of small s. Okay. So this is a semaphore. Am I passing any object here? Sorry, am I passing any count here? I'm not passing any count. That means at a time, how many can execute this one? Only one. By default, the value is what? Only one. Let us create. First, I will show you this scenario. Okay. Just I want to print something. Here I'm going to take a define show method. I want to print something. So I want to print the some name also so that you will get a clarity here. So first what I will take s dot acquire. How many can acquire this lock? Only one can acquire. Now that lock, what that particular thread has to do? I in range of, I'm going to take 10 so that we can observe the output clearly. So just I'm going to print hi. I'm going to print hi. I'm going to print hi. So whatever the name I have passed it there, just I'm going to print the name. So hi space hi comma name I'm going to print. This is my task. 10 times it has to print. Okay. After completing this task, just I'm going to release. Now tell me here, at any particular time, how many threads can execute these two statements? Okay, only one thread, because the count of semaphore is what? The count of semaphore is 1. By default it is 1 if you are not going to give anything, but I am going to give multiple threads here. So t1 equal to thread of, so what is the method name? Target equal to show. Target equal to show method I am going to take. Am I passing any argument? Yes, I want to pass the argument so that I can understand I can observe the difference. What is going to be happen by seeing that name? So T1, if T1 is executing, the name I am going to print it as what? Shiva I am going to print. Just I will keep as comma. So same scenario, I will create 2 or 3 objects. Okay. Just I will change the names. Some 5 or 6 I am going to create. Okay. Right. Now just here I will write some Ram I am going to write, and here I am going to write Channa, I am going to write some names, I am going to write Kashi, I am going to write. Okay. After that I will write some Srinu I will write, and some Raju I am going to write, and I am going to write some Vijay. Okay. These are the different names I am going to take. Just I am going to write here T2, thread 2, and thread 3, thread 4, thread 5, and thread 6, and thread 7 I am going to take. Just here to observe the output clearly, I am going to write sleep of 1. Okay, what is that? Sleep of 1 second, where it is present inside a module called as time. So just I will take 1 minute. Okay, now I'm going to take what? Import time I am going to take. Right, now observe carefully, 7 threads I have taken here. So that what I have to do now, I have to start all the threads. Just I will write t1 dot start, and I will copy all this code. Observe very carefully. Okay, it will take, if I execute this program, how much time it will take? 2, 3, 4, 5, 6, 7. It will take nearly 70 seconds. So I don't want to waste 70 seconds. Just here I'll write 5. Here I'll write what? 5. So nearly 35 seconds I have to wait for the output of this program. So what we have to observe here, how many threads are going to execute simultaneously, we have to observe. That's it. Okay, just I'm going to save, and I want to execute this program, and I'm executing. So semaphore, sorry, just I have spelling mistake we are having here. Right. So just I don't want to take here. If I take the output here, it may not be clear for you. Okay, just I will take this here. Now see, first it is going to execute what? Hi Shiva, hi Shiva. Because how many threads can execute at the same time? Only one thread. So there is no problem. First, whatever the thread it is going to start execution, there is nothing but T1. So T1 will go and it is acquiring the lock. How many members can acquire the lock at the same time? There is nothing but only one, because here I have not passed anything. So one it is going to, so that first Shiva, after Rama, after Channa, after Kashi, after Sinu, after Raju. So there is no problem here. But now see, the program is completed. After Vijay it is going to execute, program is going to be completed. But just I will change the program. Observe carefully. Just I will change the value as 3 here. The meaning of this one is what? The meaning of 3 is nothing but, first I am giving chance to T1, T2, T3, because those are in the first sequence. Next we are going to give chance to what? T4, T5, T6. If I am giving 3 threads chance, then what may be the output of my program? Hi Shiva, hi Ram, hi Channa. These 3 only will be repeated until 5 seconds. After that, sorry, 15 seconds. After that, what happens? It is going to take these 3. After that, there is only one, so that one will be executed. Observe carefully now. So now, first 3 threads maybe will be executed simultaneously. So you can't expect. See, hi Shiva, Rama, Channa, hi Ram, Shiva, Channa. These are going to be executed simultaneously, so that we can't expect. So see, after that, Kashi, Sinu, Raju. After that, only Vijay. After that, only Vijay. That means what here? You can clearly observe. I am making what? I am going to give. See here, first case here. If you observe this, up to where? Up to here. If you observe, see, Siva Ramachanna, Siva Ramachanna, Siva Ramachanna, Siva Ramachanna, and Siva Ramachanna. After that, Kashi Sinu Raju, Kasu Sinu Raju, and so on. Only those three are going to be repeated because I have given chance to execute only for the three threads simultaneously. After Shiva thread, Rama thread, and Channa thread is completed, then the chance is taken by whom? Kashi thread, Srinu thread, and Raju thread. After this is completed, then finally who has taken? There is only one thread. That thread is going to execute in our program. Okay, this is about semaphore. Here, what is the scenario internally it is going to use? Internally, again, it is also using the concept of what? Our lock and RLock concept only. So semaphore is going to use what? Sorry, not RLock. It is going to use what? Lock concept only. It is not using RLock. It is going to use what? Lock concept only. So one more point I have to discuss. So internally semaphore is using what? Lock concept. So here one point we have to understand what here we can write, we can release, we can apply release any number of times. There is no problem. Any number of times. Okay, that is if semaphore acquires 2 times, that is what if we are going to apply count as 2, release can be any number of times. There is no problem. Okay, that means what? If you want to apply, let us take one scenario here. Let us take once. So I think this is clear for you. Just I'm going to remove all this code. Just I want to show you about this releases only. I will take only about 2 things. That is what? Only T1 and T2. So here I am going to write how many I am going to give chance at the same time, 2 for example. And I'm going to apply C s dot release. How many threads are there? 2 threads I'm going to allow. I'm going to allow 2 threads, but I'm going to give you how many releases? I'm going to give 3 releases. Will there be any problem here? Let us check whether there is any problem or not. So here what happens? S is going to acquire the lock. Sorry, I have not started this one. Sorry. Just I have to start this T1 dot start, and I'm going to write T2 dot start. Right now I will execute this program. Now observe, is there any problem? The program is executing successfully. There is no problem. And it is going to do what? It is going to terminate it also. That means we can write any number of releases. But in our lock and RLock concept, what happens? If you are going to write more number of releases than acquire, we are going to get an error. Okay. So, but in semaphore, what is the concept? We can have more number of releases also. There is no problem. Yes. Here we are having one small disadvantage. That is what? Here I am going to write any number of, I can write what? Any number of count here. There is no problem for that. But here what happens? You can write any number of releases. That means what? Normal semaphore is an unlimited semaphore, which allows to call any number of releases. Okay. Any number of releases. So that what happens here? If you are going to apply, any number of releases, then what is the meaning of that one? Here, how many are there? Just I will write a small scenario here. Just here I am taking s dot, s equal to semaphore of 2. I am going to write. The meaning of this one is what? At a time, how many locks can be? How many threads can access this enter simultaneously at the same time? Only 2. But what I am doing here, s dot acquire I am going to write. So 1 acquire I am writing. So 2 are going to acquire. After that I am going to write. Otherwise I will write, okay, 1 acquire I am going to write. But release is what? Release. How many releases I have write? I have written here. I have written 3 releases. If I write 3 releases, what happens? When I'm acquiring the lock, it is going to perform minus. It's going to perform what? Minus. So if I'm going to write here T1 dot start, T2 dot start. 2 threads are there, which is executing a function called as add function, for example. So now T1 came here and acquired the lock. That means what? 2 minus 1 equal to 1. Again T2 came here and it is going to acquire the lock. That means what? 1 minus 1 equal to 0. So now how many locks are there? 0 locks are there. Now it is going to release. So 0 plus 1 equal to 1. It is going to release 0 plus 1, 0 plus, 1 plus 1 equal to 2. Next, once again it is going to release. There is nothing but 2 plus 1 equal to 3. But actually, how many are allowed here? Only 2. That means the normal semaphore is an unlimited semaphore which allows to call a release method any number of times to increment count value. See here, it is a problem here, but this is called as what? Unbounded. There is no boundary for this one. We can apply any number of releases here. That is, in unbounded semaphore, release calls can be more than acquire calls. This is the point we have to understand, so that we are having the disadvantage. So we are going for the concept of bounded semaphore. What is the name of that semaphore? Bounded semaphore. There is no, this is not a huge concept, just one point. The small difference will be there between semaphore and this bounded semaphore. That is nothing but, in bounded semaphore, the number of release calls should not exceed number of acquire calls. That is the only thing we have to observe, the difference between semaphore and bounded semaphore. That is, once again I'm repeating, in semaphore, normal semaphore is also called as, observe carefully, normal semaphore is also called as unbounded semaphore because there is no limit for the releases. Okay, unbounded semaphore. So here we are having the disadvantage. So that I am going for which semaphore? Bounded semaphore. Bounded means what? Here there is some boundary. What is that boundary? Number of acquire calls. Number of acquire calls should be equal to or should be matched to number of release calls. If you are not going to write number of acquire calls and number of release calls same, then automatically what we are going to have? We are going to get an error. Which type of error? We are going to get an error called as value error. We are going to get here. Okay, all right. So let us see the example for this one. Right, same example I will take. Now observe here, number of acquires, how many I am going to allow? 2. But how many releases I am going to write? 3. Just I will change it to what? Bounded semaphore. Remaining all are same except this one. So observe carefully. So it's going to print, it's going to print, it's going to print. Right, see here, it's going to give me what? Different errors. So value error, we have to observe this one. Value error, semaphore release too many times. What is that? Semaphore is going to release too many times. So if you want to see this output clearly, just I will show you here. Observe now. Hi Shiva, hi Ram, hi Shiva, hi Ram is going to print. So now see, semaphore released too many times. That means what? Number of times it has to be released. How many times? 2 only. But here how many times it is going to release? 3 times. So we are going to get what? We are going to get an error called as value error. So this is the concept of bounded buffer. So what is the main difference between semaphore and bounded buffer? In semaphore, number of release calls can be more than number of acquire calls. There is no problem. But in our bounded buffer, bounded semaphore, there should be a same number of acquire calls and release calls should be same. If the number of release calls is more than number of acquire calls, then what happens? Then automatically we are going to get an value error. You may get one doubt that, sir, here 2 can acquire, but I'm going to release only 1 lock. There is no problem. There is no problem here. Okay, you can observe that output also. So 2 threads are going to execute here. While leaving, every thread is going to apply what? Release. There is no problem here. Okay, so this is the concept of synchronization. So synchronization can be implemented by using 3 mechanisms. First one is what? First one is a lock concept. This is a basic fundamental lock. By using a mechanism called as lock. Second one is RLock. Third one is semaphore. Third one is what? Semaphore. In this, we can also have what? Bounded semaphore. Semaphore, and we are having what? Bounded semaphore. These are the things very important. So one thing we have to understand what here, that is the semaphore is going to use internally which type of lock, so which type of technique is going to use the concept of lock or RLock. It is going to use lock only. Okay, right. This is about synchronization, but one more point I have to discuss. Okay, right. Now let us discuss about, okay, let us see difference between lock and semaphore also, because we are using the lock internal. Yes, we are going to implement this semaphore by using the lock concept only. Let us see one point. What is the disadvantage of this? Sorry, what are the differences between semaphore and lock? That is, here if you observe difference between semaphore and lock, at a time, lock object can acquire, how many, the lock can be acquired by how many threads? Only one thread. But in semaphore, the lock can be acquired by any number of threads. It may be any number based on the value we are going to pass to that semaphore. The count value can be anything. This is the main difference we have to understand between lock and semaphore. Yes, as we have completed the concept of synchronization, just we have to see advantage and disadvantage once. So already advantage is what? We are going to overcome the problem of data inconsistency. Data inconsistency will not be there. Okay, avoiding data inconsistency. Then what is the disadvantage? Remember one thing, if you are having an advantage, there will be a disadvantage will be there compulsory. That is, so here what happens? One at a time that is going to execute. One at a time it is going to execute. One at a time it is going to execute. Let us consider there is a task which will be completed in 2 minutes. I am going to apply this synchronization for this task. Then, okay, lock I am going to apply. I am not applying semaphore. I am going to apply a lock. So 10 threads are waiting to execute this task. How much time it will take to complete this task by 10 threads? Only one thread at a time has to execute. First thread 2 minutes, second thread 2 minutes, and so on. 10th thread 2 minutes. Total time taken how much? 20 seconds. Okay, 20 minutes, sorry, 20 minutes. If I am not going to apply the concept of the synchronization, it may take only 2 minutes, or at max it may take only 3 minutes. That means what? By using the concept of synchronization, waiting time of threads is going to be increased. Waiting time of threads is increased. Okay, so that what is recommendation means, I'm going to recommend you, if there is no need of synchronization, then don't use the concept of synchronization. Whenever there is a need of synchronization only, it is recommended to use this concept. Otherwise, don't go for the concept of synchronization. So this is about the concept of synchronization. But here some points I have to relate to our previously discussed concepts. Those are what? One is, so already we have discussed about what exception handling we have completed, and also we have completed the concept of files. So there I have discussed one important point, that is what? If you are going to acquire a lock, it is compulsory to do what? It is compulsory to release the lock. If you are not going to release the lock because of some problem in my code, then can another thread can acquire that lock? It is not possible. So that I have to do some mandatory things are there that we have to do compulsory when we are going to apply the concept of synchronization. So that things I am going to explain now. That means what? Compulsory, if you are going to use the concept of synchronization, it is highly recommended to release the logs. So better write the concept of releasing the lock inside a finally block. What is that? Finally block. So just I will write a small code for this one, so that you will get a clarity on this one. So here I have taken one function, and in this what I will write this code inside a try block. I am going to take, right? Now observe. So where release has to be there finally, because if there is any problem, already here acquiring is done. If there is any problem in this code also, there is no problem. The code, the release finally will be executed 100%. So the lock will be released compulsorily. So already I told you, when I was discussing about the concept of finally, I told you that if there is an exception, if there is no exception, if there is if the, what I can say, if anything, if there is an exception, if there is no exception, if the code is handled, if it is not going to be handled, there is no problem. Finally is going to be executed. Anyway, there is, the program will be executed as it is. But here, this is a good programming practice. If you use the concept of this type of releasings, then or some closing of the files, better write this type of closings or releasings or freeing any memory inside a finally, then compulsory that statement is going to be executed. So this is the first point we have to understand. So here you cannot what we can say, output will not be differentiate, but internally we can observe that. Okay, right. So this is about one of the good programming practice when we are coming for the concept of synchronization. And second one, so anyway, I have shown you the concept of with statement. So in with statement also, if I am going to open a file with the help of with statement, there is no need of closing. So in the same way, observe carefully. Here if I am going to write with lock means the lock is going to be applied. Just I will show you that concept so that you will get a clarity on that one. That means what? With file, that means what? With open as if you are going to write, then just I am going to perform the tasks and I am not going to close that file, because with I am going to use with the concept of with. So now observe carefully. Just I am going to use this statement called as with. Before that, I will create a lock. Just I will write a L equal to normal lock I am going to take. Okay, I have taken lock here. So I want to write one function, define. Just I am going to write a function called as show function. Same function I am going to write, and here I am going to take name. So observe carefully. Now I am going to apply what? Lock. I am not going to use acquire. With L I am going to write. If I am going to write with L, it indicates what? Acquiring the lock. So just same thing I am going to write. For I in range of 5 I am going to take. That means whatever the code I am going to write inside this for loop is going to be executed how many times? 5 times. Same scenario, that is what? Hi Shiva I am going to write. Okay, right. My task is completed. Just I will sleep for 1 second. So to observe the output clearly, I am going to write time dot sleep of 1. Now observe carefully. Here, am I doing any releasing concept here? I'm not applying any releasing here. So let us see what will be the output of this program if I execute without having. So here, 1 minute. Here I have written some mistake, I think. Sorry. Here I have to write what? Name I have to write. Okay. Right. Now observe here. So see, hi Shiva, it is printing clearly. After printing hi Shiva only, it will print what? Hi Ram. Because what? Synchronization is applied here. I have applied lock. Okay. See, it is printing clearly because with L means with this L only one can execute. If anyone is entering into this code, only one can enter because of this L here. This is a lock and no need of releasing the lock. Automatically lock will be released with the help of, if we are going to use the concept of with the statement. Okay, so it is recommended to use whenever you are going to use the concept of synchronization to release the lock. It is used it is better to use finally, or it is better to use with the statement. Okay, so this is about the concept of synchronization. And so how many techniques we have seen, or how many mechanisms we have seen here? 3 mechanisms. One is what? Lock, RLock, semaphore, and we can also consider bounded semaphore also. Okay, so in next session we are going to see the concept of inter-thread communication, which is also an important concept in multi-threading. Thank you.